Hello, good morning, students. Today we will study classification of organic compounds. We know there are many organic compounds, many crores of organic compounds, and there are different ways to classify these organic compounds. That is on the basis of structure, on the basis of chemical properties, on the basis of carbon skeleton, and on the basis of functional group. Today we will study this classification of organic compounds on the basis of carbon skeleton, and that is the important way of classification of organic compounds. So on the basis of carbon skeleton, these organic compounds are mainly classified into two types. First type is alicyclic. Meaning of alicyclic is a compound containing carbon, carbon, carbon long chain, which is open chain of carbon atom, not closed chain. These compounds are also called as aliphatic compounds. They are open chain compounds of carbon. And other type of organic compound is a cyclic compound. They are also called as a closed chain compounds. In this type of compound, there is carbon, 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 a long chain, and but the end carbon atoms in this chain, they are joined together so that a cyclic structure is obtained. Closed chain structure is obtained called as a cyclic compounds. These aliphatic compounds are further classified into two types, that is saturated and other type is unsaturated. In saturated compound, this carbon carbon single bond is present, and in unsaturated compound either carbon carbon double bond or carbon carbon triple bond is present. We know carbon carbon single bond containing compounds are called as alkanes. Then carbon carbon double bond containing compounds are called as alkenes, and carbon carbon triple bond containing compounds are called as alkynes. So in the next chapter we will study in detail about this alkane, alkene, alkynes and aromatic compounds. So that is about the first type of organic compound, acyclic, or they are also called as aliphatic. Then the second type of compounds are the cyclic compounds. As we had already studied that this cyclic compounds contains a closed chain of carbon atoms. They are further classified into two types. One is homocyclic and other is a heterocyclic. In homocyclic, there is a ring or the closed chain of carbon atoms only, and in heterocyclic compound a ring of carbon atom, cycle of carbon atom, along with this one heteroatom like nitrogen, oxygen or sulfur is present in the closed chain. Therefore they are called as a heterocyclic. Hetero meaning is different and homo meaning is same. So same type of atoms form a closed chain, and here carbon and other atom like nitrogen, oxygen or halogen or sulfur, they forms a closed chain compound called as a heterocyclic compound. Now these homocyclic compounds, they are also called as a carbocyclic compounds. Why? Because here the carbon atoms only form the closed chain or the cyclic compound, hence called as a carbocyclic. These homocyclic compounds are further classified into two types, that is alicyclic and aromatic. These alicyclic, these are again closed chain compounds of carbon only, and they contain carbon-carbon single bond in their molecules. Therefore, they are called as a alicyclic compound. Here, we can consider the example of alicyclic compound as a cyclopentane. This contains 5 carbon atoms. At each corner there is a 1 carbon, total 5 carbon atoms, and a closed chain of carbon atoms with single bond. It is a cyclopentane. Like this, we can have different examples of this type, that is a cyclopropane, 3 carbon containing, cyclobutane, it is a 4 carbon containing, and cyclopentane is 5 carbon containing. So like this, we can give the different examples of alicyclic compounds. Now, other type of homocyclic compound is a aromatic. Homocyclic compounds, these are aromatic type. In this type, these aromatic compounds, they have carbon-carbon single and double bond in alternate position. That is called as a aromatic. Here, aromatic compounds are further classified into two types, that is benzenoid and non-benzenoid. This benzenoid have benzene-like structure. We know structure of benzene very well. It is a 6 carbon containing closed chain with carbon-carbon single and double bonds in alternate position. That is the structure of benzene, and this type of structure is present. Then the aromatic compounds are called as a benzenoid aromatic compounds. Other example of benzenoid aromatic compound is a naphthalene. So naphthalene is a two benzene ring when fused to give this type of structure, that is called as a naphthalene. So naphthalene is other example of benzenoid aromatic compound. Now we will study this non-benzenoid aromatic compounds. In non-benzenoid aromatic compounds, they are the closed chain compounds of carbon again, and they contain this type of benzene like structure, but it is a 7-membered ring and containing double bond and single bond in alternate position, but at these two positions there are only single bond adjacent position, but there is a heteroatom is present at outer side of this ring, and the name of this compound is tropone. So tropone is the example of non-benzenoid aromatic compound. Like this, other examples of this non-benzenoid compounds are also there. So we will study these compounds again as additional examples under this type. Then the second type of cyclic compound is a heterocyclic compound. From this name, the meaning of hetero is a different, and cyclic means a closed chain compounds. So it is a closed chain compounds of carbon and other atom like heteroatom like nitrogen, oxygen or sulfur present in their rings or in the closed chain. They are called as a heterocyclic compounds. These heterocyclic compounds are again two types. One is aromatic and other is a non-aromatic. Meaning is, in this type of compound, again there is a heteroatom is present. For example, we can have the example of this type, that is heterocyclic aromatic and heterocyclic non-aromatic. Here the furan is 5-membered cyclic compound containing 4 carbon atoms and one is heteroatom like oxygen. Here, carbon-carbon single and double bonds are in alternate position. Similarly, thiophene, instead of oxygen, there is a sulfur atom. Then pyridine is a benzene-like structure with nitrogen as a heteroatom. Then pyrrole is a five-membered compound containing four carbon atoms and one nitrogen with hydrogen with alternate single and double bonds. So these are the examples of heterocyclic aromatic compounds. Remember these names well: furan, thiophene, pyridine, and pyrrole. Now we will consider the examples of heterocyclic non-aromatic compounds. These are the examples of heterocyclic compound, meaning they contain heteroatom like oxygen or nitrogen or oxygen or sulfur. So here in these compounds, carbon-carbon single and double bonds are not in alternate position. Hence, they are not aromatic, hence called as a non-aromatic. Here, from this furan, if we add across carbon-carbon double bond, here hydrogens are added, then it becomes saturated. So it is a tetrahydrofuran called as. It is a heterocyclic aromatic. Next example is obtained from pyridine. By removing double bond, we get a single bonded compound with nitrogen. Valence is completed as a 3 with hydrogen, and name of this compound is piperidine. Then next example is 4H pyran. This is 4 hydrogen containing pyran. So that is the example of heterocyclic non-aromatic compounds. So in this way, these organic compounds are classified into different types. Like we had studied, organic compounds are two types: alicyclic and cyclic. Then cyclic further classified into homocyclic, heterocyclic. Homocyclic are further classified as alicyclic and aromatic. These aromatics are two types: benzenoid, non-benzenoid, and heterocyclic are also two types: aromatic and non-aromatic type. So when carbon atoms are bonded to each other in a core of organic molecule, that is called as a carbon skeleton. Means how carbon atoms are bonded together, in which manner they are bonded, that is called as a carbon skeleton. And on the basis of carbon skeleton, there are variety of organic compounds. That is the classification of organic compounds on the basis of carbon skeleton. We had studied this acyclic, or they are called as open chain or aliphatic compounds. In these compounds, they have the carbon chain. It may be straight chain or it may be branched chain. So in this table number 14.2, different examples of alicyclic compounds are given. One is propane. It is a CH3, CH2, CH3, three carbon atoms in a straight chain. It is an example of alkane with three carbon atom in a straight chain. Then it is again three carbon containing compound, but OH as a functional group. So it is N-propyl alcohol. That is a normal propyl alcohol. It is again straight chain compound of carbon with functional group OH. Then here one example of branched chain containing alkane is given. Here three carbon atoms in a straight chain, and middle carbon atom, it is bonded with CH3 group. So it is called as a branch or side chain. Hence this is the example of branched chain hydrocarbon or alkane, and its name is isobutane. Then second type of organic compounds we had already studied in the tree classification. So it is Cyclic compounds, they are the closed chain compounds of carbon. They are homocyclic, containing only carbon atoms, called as a carbocyclic, and other containing heteroatom like oxygen, nitrogen or sulfur in their molecule, called as a heterocyclic compounds. These examples are cyclohexene. So cyclohexene is homocyclic compound containing only carbon atoms, but there is a one carbon-carbon double bond. Hence, it is a cyclohexene. If there is a no double bond, then it will be cyclohexane. Then other example of heterocyclic alicyclic compound is a piperidine. So it contains a single bond, closed chain with heteroatom. Then next is cyclopentane containing 5 carbon atoms in a closed chain, and there is a no heteroatom, therefore it is a homocyclic and alicyclic type. It is a benzene, it is aromatic and homocyclic type, benzenoid aromatic. Then this is heterocyclic aromatic compound, and example is pyrrole. Then alicyclic compounds we had already studied. These are classified into different types, like these are cyclobutane is alicyclic. This cyclohexene is also alicyclic compound, homocyclic, that is coming under alicyclic type. Benzene and naphthalene, these are the benzenoid aromatic. This phenol and tropone, this phenol is aromatic and tropone is non-benzenoid aromatic. Then other examples, these are heterocyclic aromatic, we had already studied. Heterocyclic non-aromatic, that is also we had studied. And that is about the classification of organic compounds on the basis of structure or the carbon skeleton. Thank you.